and today we'll be talking on the three laws of motion, which is Newton's law of motion. You must have heard about Newton's law of motion and how they work. So in this video, we quickly look into the three laws of motion, know how to apply them when needed, and also know how to state them. Please join me as we go into this. Let's move straight to the notes. Okay, now looking at this, you see Newton's law of motion. It said the problem of motion and its cause were the central theme of natural philosophy. It was not until the time of Galileo and Newton that some progress were made. Isaac Newton, born in England in the year that Galileo died, was the principal architect of classic mechanics. He completed the work on the ideas of Galileo and others who preceded him. Now, from what we saw there, it's trying to tell us that there was a man named Isaac Newton, and there was a problem to understand how motion moves and the causes of motion and so on and so forth. So Sir Isaac Newton was born in the year when Galileo died. So when Galileo died, there were some ideas that Galileo had and some other scientists as at that time they had all of these ideas, but the ideas were not put into work. Or should I say they were still processing those ideas. So when Sir Isaac Newton came into the game, he found those ideas and also his own idea. A combination of all of those ideas bets to what we see today as the three laws of motion. So he used all of those ideas, combined them together, including his own idea, and profound the three laws of motion. So let's proceed with the notes, please. He said the study of objects in motion or their state of rest fall under the scope of dynamics. The application of force may change the direction of motion or the state of rest of an object. Newton's three laws of motion, published in 1686 in his great work, The Mathematical Principle of Natural Philosophy. So this mathematical principle of natural philosophy illustrate the rules of force in dynamics. Newton's first law. Newton's first law states a body remains at rest or uniform motion unless it is compelled by an external force to act otherwise. Now we can see what Newton's first law is stating. He said a body at rest will continue to be at rest, or a body in motion will continue to be in motion unless it is being acted upon an external force to change its position. That is to say, if a body is seated, it will continue to be in that sitting position unless an external force acts on that body to move. And also a body that's moving in motion, for example a car that's moving, that car will keep moving unless it is being acted upon by an external force to stop moving. Such example is when you're moving your car, the car will continue to be in motion unless you match the brake for it to what slow down and stop eventually. So that's what the Newton's law of motion states, and that tendency for a body to be at rest or continue in uniform motion is known as inertia. The inertia of that body, that is what it means for a body to be in rest or in motion, continuous motion, or be at rest at any given time is known as the inertia of that body. So he said the tendency of a body to remain in a state of rest or uniform motion is known as the inertia of the body. Thus, Newton's first law is called the law of inertia. You see, I just said that it said the law, a body at rest continue to be in rest, or a body in motion is known as the inertia of that body. So Newton's first law of motion can be regarded as the law of inertia. Okay, so let's move down to the second law of motion, which is Newton's second law of motion. Okay, so this is Newton's second law of motion, and it states that the rate of change of momentum per unit time is directly proportional to the applied force and takes place in the direction of the force. Newton's second law is telling us that the rate of change of momentum is directly proportional to the applied force and takes place in the direction of the force. That's basically what it means. So we're going to see this mathematically on the note. Everything is being drafted here out, and we're going to proceed with the note, please. Now look at it. It said F, which is force, is equal to change in momentum all over t, which is time. So F is equals mv minus mu is change in momentum all over t. And here we, since m it's common, we factorize it. So we have m into bracket v minus t all over t. And v minus t is known as acceleration, because acceleration is the rate of change of velocity with time, and we have v as our final velocity and u as initial velocity. So v minus u all over t is regarded as a, which is acceleration. So Newton's second law of motion can be defined as F equal to ma, which is mass multiplied by acceleration, where a is acceleration, F is the net force, and m is the mass of the body. Now, Newton's second law of motion can therefore be stated as the acceleration of a body is proportional to the resultant force acting on that body. You can see from what we all did there, when we said is the rate of change of momentum, trying to solve momentum, we now saw that v minus mu, which is rate of change over momentum, all over t, which is time, can also be written as m into v minus u all over t. And v minus u all over t is defined as the acceleration of a body, because acceleration of a body is the rate of change of velocity with time, and we have initial velocity, we have final velocity. So initial velocity changes to final velocity. That's why we have the v minus u all over t. So v minus u all over t is regarded as a, which is acceleration, and so F now becomes, instead of mv minus mu all over t, becomes ma. So let's proceed down. Newton's second law can also be deducted into different forms, into the impulse form, into impulse equals to momentum and all of that. So let's dive into the note also to see that for ourselves. Now we have F equal to mv minus mu all over t. Now if we cross multiply, we'll have ft equals to mv minus mu, and ft is equals to impulse of a force. Impulse is defined as the product of a large force and a very short time during which it acts. The unit for impulse is Newton seconds. Since impulse is equal to change in momentum, it means momentum can be expressed in Newton seconds. Now let's look at an example. Let's solve an example. Example 1, it said a block of 20 kg mass is pulled horizontally by a force of 10 Newton along a frictionless floor. Find the acceleration of the body. Now, in this problem, we have the mass of the body, which is 20 kg. We have the force, which is 10 Newton. And now we are asked to find the acceleration of this body. So we're going to use that formula of F equal to ma, and now we'll make a subject of the formula and then we'll solve. So let's proceed with the notes and see how it goes. Okay, so here we have F equal to 10 Newton and M equal to 20 kg, and A is not given. So F equal to MA, and we'll make A subject of the formula by dividing both sides by M. So A is equals to F over M, and A is equal to now 10, which is F force all over mass, and the force is 10 Newton and mass is 20 kg. So 10 divided by 20 is 1 over 2, which is also 0.5. So 0.5 meter per second square is our acceleration. That's the answer. Now let's proceed to Newton's third law of motion. Newton's third law of motion. The force that one object experiences due to the presence of another is equal in magnitude but opposite in direction to the force that the second object experiences due to the presence of the first. It can also be stated as to every action there is equal and opposite reaction. Now, this law of motion is trying to tell us that to every action there's equal and opposite reaction. That's basically what this whole thing is saying to us. So let's go down to some examples to solve and see how it works. A body of mass 4 kg undergoes a constant horizontal acceleration of 3 meters per second. Calculate the resultant force acting on the body. What will be the resultant force on the body when it moves with a uniform velocity of 6 meters per second? Now, this is the solution. We have the solution here. We have A 3 meters per second square and M equals to 4 kg. And we are to calculate the resultant force in the first instance, which is F equals to MA. So F is equals to 4 times 3, which is 12 Newton. Now, we are to calculate the resultant force also if when the body moves with a uniform velocity of 6 meters per second. Now, we now said if the body moves with uniform velocity, it means that it is not accelerating. That is, A is equal to 0. Therefore, the resultant force on the body is 0, because if you multiply the mass times the acceleration, which is 0, it will give you 0. So F now will be equals to 0 because the body was not accelerating. Now, if we use the M, if we use the first equation, which is F equals to mv minus mu all over t, is the same thing, because we have 6, the velocity, initial velocity will be the same as the final velocity, so it will be 6. So when we multiply through minus minus, it will give us 0, and 0 divided by the time, now it also gives us 0. I hope you understand it right now. Let's go to another example. It said a body of mass 6 kg moving with a speed of 20 meters per second is suddenly hit by another body moving in the same direction, thereby changing the speed of the former body to 50 meters per second. What is the impulse received by the first body? Now look at this. Now we have two velocities, right? We have initial and final velocity, and we said impulse in our previous calculation, where we have ft equals to mv minus mu, and we said ft is impulse and mv minus mu, it's what the change in momentum. So our impulse now will be equals to mv minus mu, and we make m the factorize m because m is common. So m now will be equal to, I will be equal to m bracket v minus u, and we have our mass at 6 kg, which is 6, and we have final velocity of 50 and initial velocity of 20. So 50 minus 20 is 30, and 6 multiplied by 30 will give us 180. So impulse now will be equal to 180 Newton seconds. Let's move straight to another problem. I think this should be the final problem for this particular lecture. A body has a mass of 2 kg. Calculate the force which acts on the body. On this body will produce a force of 3.6 meters per second in a time of 12 seconds. Now, how do we do this? Now, our formula is F equal to ma. So for us to get the acceleration, the value for the acceleration, it should be velocity over time, which is 3.6 all over 12, which will give us 0.3 meter per second square. Now we have our formula F equals to ma, and F equal to, what's our m? 2.0, which is 2 kg, multiplied by 0.3, which is our acceleration. So our answer should be 0.6 Newton, and that is the answer. Thank you. Now we have seen the answers. We've seen how to solve problems involving motions, right? Now, thank you, and we'll see in our next class. Please, if you have any question, please ask your question in any area you're not too clear. I'm here for you. I'm here to answer. Please drop it on the WhatsApp group.
Quiz.